Yep, my name is Paul Emerson. I'll be giving you my 2 cents. I am doing my homework for Programming 1 at Fullsail University. It's going to be super boring. Um, yeah, I'm just learning how to program and I'm recording my progress. That's it. Nothing fancier than that. Thank you for tuning in.
Alrighty, we are ready to get started. My voice is at about 30% right now, so hopefully you guys online can hear me. I am otherwise mostly fine, so we will see how this all goes. So we're gonna start off with our poll. Get into it. Oh, no, wait, hold on. My screen capture is not on my screen because I'm doing lectures for home as well. So let me just come here and here. And there we go. Hop on in, get you guys situated.
Thank you. I gotta take my trash out. I need to be a responsible adult.
Alright, kick it off. Like I said, these are all opinion polls, but there are some wrong answers.
Welcome to the live stream.
It was a bold move, but you know what? I like it. It's a good game. Titanfall 2 is also a bold move, but you know
What is
what?
the best video game of all time
like
is
it.
the question.
Best game of all time. I'm trying to find out the soundtrack of Titanfall 2. And damn it, he's not going to Grammy this year. The Titanfall 2 soundtrack is up for Grammy consideration. So like when I was growing up, I played Kingdom Hearts. I didn't play Kingdom Hearts. I saw Kingdom Hearts. I remember I went to Epcot, and Kingdom Hearts was at Epcot. And when I was there, it was like the most incredible thing I've ever seen in my life. The gameplay was fun. It was an adventure RPG. Disney characters. There was Final Fantasy characters, and I never got a chance to play it. So like when they released the big like mega pack for PS4, I went and I bought it. And I played through all Kingdom Hearts 1. Like this game is fine. It's a PlayStation 2 game. And then I played through, I want to play through them in chronological order, so I was playing PSP one. I forget what it's called. Man, after that point, I was like, maybe I'm exhausted with Kingdom Hearts 4. And I never made it to Kingdom Hearts 2. For those of you who have never played Kingdom Hearts, or have a vague idea of what Kingdom Hearts is, the crux of the entire story of Kingdom Hearts is there was an old guy, and he was evil, but he needed a young guy body for reasons. And there was a young guy, and he went to a bunch of Disney worlds because he wanted to be a hero. Except in every single Disney world he goes to, the first person he meets is the villain, and they're like, I'm the good guy. He doesn't question that at all. Like he goes to Peter Pan world, Captain Hook's like, that Peter Pan guy keeps stealing half my gold. He's like, I get that, Peter Pan. So like, that one was not that bad. The real bad one was when you get to Cinderella world, and Maleficent, looking like Maleficent, is like, I'm the good guy. You're like, alright, I'm gonna buy that. Conan Exiles, man, whoever said that. I played Conan Exiles, okay. I've seen the things that happen in that game. You know what? Like Park Survival 2, I haven't got a chance to play it because every time we play a survival game, they like null it. And they're like, oh, you can just have this stuff, and then that's not the game I want to play. But there's no bad options here except for 2. Unless that was, and I know that was dropped off too, whenever I typed it up there. No, Payday 2? There you go, that's not my guy there. We'll get into it later on. What's your most played game? My 3 most played games are Valheim, Payday 2, and my World of Warcraft character is almost 500 in-game days old. So, oops. And that's just my name. But yeah, no bad answers here. I don't think, really. Rust, maybe. I don't know. People really like Rust. Alright. Next up. Where's my next slide? What do we have? Do we need me to discuss today, if anything? By now, some people, I imagine, are in panic mode. Either A, because everything is due today, and you haven't worked on it, really, except for maybe Saturday night and Sunday during the day, or B, because we got a lot moving now. We got a lot of moving parts. We started off early with just variables, and then we started off with very simple calling methods on Wednesday, and now you are creating methods as well as calling methods. So I understand we have to do a lot of vocabulary at you, especially when you deal with the anatomy of a method, right? You get the parameters and the returns, the return type, the return statement, and the arguments versus the parameters and all that stuff. So it's a lot of stuff. Really, it gets packed into that second half of that first week. So, calling a method. So we got calling a method. Anything else? Moving up Visual Studio Code real quick. I'm also going to turn on this music, it's a little loud. Nope, I don't think if I monetize, I already did. Saving. Fine. Real quick. General overview. General overview happens every day. We'll get there. Alright. So calling a method. So, let's say I have a method. My method is, returns a string. I'm going to string data out of this. So at the end of this method, the result should be a string, right? Some type of string data. Let me switch over here. So at the end of the day, when this method is done, there should be some kind of string value, right? I'm going to call it, we'll call it hello world for now, just as an example. So here's hello world. All this thing does is we'll call it get hello world, or say hello world, say hello world. Now we'll say get hello world. There's a reason for me going back and forth on that verbiage, and I'll show you what I'm saying. And then all we need to do is we can say return hello world. Right? So there's our method. That's all it does. It says return hello world. So now that it's got a string return type, right? Like I said, at the end of the day, when this method is done, we will receive a string value. That is the agreement that we made by setting a return type of a string, is that 100% of the time when this method is done running, when we call it, we will get some string value, right? So now I can use it any way I would otherwise use a string value. So for instance, I could come here and say std string hello world, and that is equal to get hello world, and it's a string value, so that's going to be fine. I could also say std cout get hello world. That's the same thing, right? So right now, when I'm calling this method, the parameter list, when the method was defined, requires no parameters, right? So there are no parameters within these parentheses. Parameters, as a reminder, as a review, would be placeholder variables that we can assign values to when we call the method. There are no placeholder variables defined within the parameter list, so when we call the method, we still have to put the parentheses so that way the compiler knows it's a method, but we don't need to pass any arguments. So we just say hello world, we get hello world with no parameters. I mean, I don't need it there. It would work either way, but yeah, I see what you're saying. Any questions about this so far? Cool. So to see a different example, we are going to say int sum, and we're going to have two integers in here. So there's going to be a sum method. It's going to add two integer values together. So we're going to say term one, because that's what when you have a math equation.
So if name is string hello world dot empty, you want to hear what ChatGPT had to say?
Looks like you tried to define a function inside another function's body. In C++, that's not allowed. Only lambdas local classes can live inside a function. A normal function like getHelloWorld must be a namespace, global scope, or be a member of a class. Once you have anatomy-wise, you can see the code in our conversation history. Then you call it. You can see the code in our conversation conversation history. If those calls are inside main, that's fine, but the definition of get hello world must not be inside main. Fix 1, put the function at namespace scope above main. You can see the code in our conversation history. Fix 2, forward declare, then define later. You can see the code in our conversation history. Fix 3, if you must keep it inside a function, use a lambda. You can see the code in our conversation history. Tiny bits from your screenshot. Make sure you include IOString. And hashtag include string. Variable name hello world looks like a typo. Maybe you meant hello world, but either is legal. Your code uses stead code instead string, which is good. No using namespace std needed. Bottom line, move get hello world out of any other function or convert it to a lambda so its scope is correct. Then your calls will compile and run.
But we don't need to pass any arguments. So we just say hello world, we get hello world with no parameters. I mean, I don't need it there. It would work either way, but yeah, I see what you're saying. Any questions about this so far? Cool. So to see a different example, we are going to say int sum, and we're going to have 2 integers in here. So there's going to be a sum method. It's going to add 2 integer values together. So we're going to say term 1, because that's what when you have a math equation, the numbers are called terms, terms versus the operators, which is like plus, minus, and stuff like that. And then we're going to say int term 2. So this method, unlike get hello world, says it needs 2 parameters. So that means whenever we call this method, again, these are placeholder variables, right? Whenever we call this method, we must provide these variables with values. Now, these variables are set up in order for us to use those values that we receive inside of the body of the method. So we should do that. So I'm going to do the pattern that I've outlined for you guys in those videos. So I have an integer return. I'm going to make it int sum value. I'm going to set it to a default value. Then I'm going to return the sum value, right? And then in here, I'm going to say sum is equal to, my tab spacing is off for some reason. Sum is equal to term 1 plus term 2. So that's me using those two. So these parameters are going to receive values as arguments. They're going to use those two here, add these together, set them equal to sum, and then return the value out of sum. So over here, again, this method has an integer return type, which means when this method is done executing, we will have an integer value. That's the agreement we made. So we're going to come down here and make a new method, or new variable called int_sum. It's going to be equal to the sum. And I can just pass in two values here that will be assigned to these terms, right? So this is an argument. Argument is the value. This is the parameter. Parameter is the variable. So this argument value is assigned to this parameter variable, so we can use it here. Same thing here. This value is assigned to this variable. We can use it here. So it's going to go in the order that we add them. Are there any questions about any of this so far? So, like I said before, a lot of the method comes down to understanding the vocabulary and the anatomy. And once you can understand, like, parameters are a placeholder variable that we can use inside of the body that we use to get data in from the outside. Arguments are the data that we send to the method when we're calling it, right? The values that we send to the parameters and assign to the parameters when everything is called. Once you get all that verbiage down, you're good to go. Over the weekend, somebody asked, I think it was yesterday, somebody asked on Discord, are there any other resources for methods that they could look at? And the truth is, like I said before, this class is mostly programming agnostic, right? It's language agnostic, which means that any resource you look up for any single programming language for methods should be something you can use. You have to remember, though, whenever you look at an external resource, to link it back to one of the first-party resources that we use here, so that you can understand the context of that within the class, right? And number two, not all languages are, while almost every single language out there will have some type of method in it or function in it, not all languages out there are type sensitive like C++. So for instance, if you were to look up resources for functions and find information on JavaScript functions don't require you to define a type, right? They just exist because anything can be any type of JavaScript. So you would want to stick to type strict resources like C, C#, C++, Java. Those are probably your primary resources because all those languages are effectively interchangeable. And that's true for literally anything that we talk about in this class. You can use resources for just about any single language out there with a minor note for both Python and JavaScript because they're popular, but they're weird. They're a weird one of the bunch. As far as if statements go, or conditional statements that we're going to talk about today, practically interchangeable for anything else. Let me check my phone. We still have a void method. That's a good question. It's not actually a method. It's actually a type. So, like I said, I was going to come back to this, so this is a good full circle. Remember when I came up here and I said this is get hello world? I named it get hello world because it's providing a value, right? So when I want to get something, when I want to get hello world, I'm going to call this method. And this method, by virtue of its identifier, describes that it returns a value. That makes sense. And you as you go through, as you learn more about programming and stuff like that, you'll start to recognize some of these patterns, and you'll start to fall into a pattern of how you like to name stuff. Nobody is the same, obviously, but there are some things that are recurring themes sort of. All right. So void is a type, and we use void as a type in a method that does not require a value back, right? So the two methods that we've done so far, the first one, get hello world, results in a string, right? So like I said before, anytime that we run that method, it will result in a string, so we can reliably use that method as a string value because it will always result in a string value. That much we know. Same thing with sum, right? Sum will always and result in an integer value because it has an integer return type. So anytime that we use sum, we could otherwise use it anywhere we could use an integer, which means, by the way, if I wanted to come here, and since sum has two integer parameters, what I could do is I could say int sum is equal to the sum of 1 and 2 and the sum of 3 and 4, or 3 and 5, because these are integer values. I know, you would never do this kind of, I'll say you'd never do this kind of thing, but you generally avoid this kind of thing because this is confusing. If you did something like this, it would look like this, just to make it easier to read. But I digress. Void is another type of return type. However, what void means is that nothing comes out. You're just throwing stuff into the void. It goes in, doesn't come out. All right? So, whereas I said get hello world here, what I would instead say here is something like print hello world, right? And then inside of this method, I would do that std cout hello world. And that's it, right? So I don't need anything out of this method because the point of this method is for me to print something to the console. It is not for me to get a value out of it, right? I'm not sending in values to get values out. I could still send values in here if I wanted to like print some kind of specific thing. Spoiler alert, we're gonna do that in the Pokemon demonstration today. But in this particular circumstance, I don't need to do that. This is just simply print hello world. That's all I'm asking you to do. Don't give me any values back. Any questions about that? As a side note here, anytime that I create a new method, I'll probably just mark it as void by default until I really have an understanding of how it's going to work, and then I'll come back and I'll change the return type of it. Just because you need a return type to define a method, and I'll just put void and do everything, and then once I get to the end of it, I'm like, okay, this is the process here, then I'll move back. All right. Are there any other questions before we move on?
On that, maybe it's semantics or whatever, I'm confusing myself, but the way I understand when you're using void, you're always going to output something to the CI. Like whether it's lines or words or whatever. You're just not requiring user input.
Well, the input is not the input is not important. The output is what's important. The result is what's important, right? But it's not it doesn't necessarily have to print something to the console, right? That is just the context that we have based on what we have in the context of the application that we have. For example, okay, let's say I am making Mario, the original Mario. All he does is run and jump, right? So there are things that Mario does that results in some type of feedback, right? So for instance, when he gets hit, something happens, and he either dies or gets smaller, right? So like at one point where his sprite comes in collision with another particular type of sprite, if he is big, he goes small, and if he is already small, he dies, right? So there is a result, like that collision gets pushed somewhere and it has some kind of result. However, there's also like a button press, right? So when I press a button, Mario jumps. He jumps up into the air, which effectively, in the context of the game, means that his sprite goes, the Y position of the sprite increases over time and then decreases back down, right? That doesn't need me to get any feedback. That is the feedback, right? So it's like on button press, it increased by Y and then decreased by Y. in the context of that game, right, that visual representation is your C out. It is the right to the console. It is not necessarily, that particular thing is triggered by a user action, right? But at the end of the day, that's all it needs to do. We don't need a number back from that. We don't need words back from that. Like, you could maybe arguably get a bool back from that. It says, like, press a button, jump up in the air. If you did a jump with successful, return true, but that's arduous extra steps. It's not really necessary. Does that make sense? Yeah. Alright. So, it's time for us to get into our today thing. Now, before we get started, let's create some context, because we're going to see the demonstration later on. So let's remember where we are, right? And get an idea of where we're going. Not the soundtrack. Alright. So here we are, back in Pokemon Red Gen 1. A lot of stuff going on, blah, 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 blah. We mentioned on Monday or Tuesday, hold on, I'm doing this in the wrong order. We mentioned on Monday or Tuesday that games are either parkour or menus, and Pokemon is menus, right? So here we are in Pokemon, which, as we said, is menus. As they go through this game, you'll see more menus, right? So everything that we have made up to this point, right, has been linear. So it's been start to finish. At the end of the day, even when we call methods, right, those methods are still executing top to bottom. Just boom, just point A to point B. So we know if we start our application, because we talked about this before, the main method is the primary entry point of our application. The whole application exists within the entry point. So if we run our application right now today, and we don't change anything about the code, right, the main method is going to run. It's going to hop over to some other methods. At the end of the day, the outcome is going to be the same every time, right? No difference, because all it's doing is reading a set of instructions, top to bottom. Today, we're going to start talking about decisions and branching statements, which means the end result of any of our application or any particular method or whatever it is we're working in may not be the same, and it will change conditionally. Conditionally meaning it will change based on something, right? Whether that be user input, it'll change based on values or something like that, right? Something will happen at some point that will branch off our application and have us doing something different. So right now, when we're looking at this menu, right, the user has two choices. They can start a new game, or they can go into the options. They can do either one of those things, right? And whatever they do is going to change this playthrough from a potential previous playthrough. Because if we didn't have a branching statement, you would go from straight from the menu, into new game, into the next thing. You would have a predefined name, so on and so forth. Does that make sense? Any questions about any of that? Cool. All right. Let's get into some slides. I'm sorry, it takes forever for me to open these slides because I have to connect to the internet. Why? I was so hopeful about the internet when I was a young child, sitting in my AOL chat rooms, talking to strangers with too many X's in their names across the country. Now we got way too much internet. There's too much in it. We have dialed the internet back, man. I don't need to open PowerPoint across the internet. That's not a thing I need. All right. So, before we get started, at this point, these are the things that we should be understanding. Number one, you guys should know all of the different C++ primitive types. That is your numbers, your ints, floats, and doubles, your Boolean types, your bools, your character and your word and letter types, which are going to be char and string. Those are going to be the basic building blocks for everything that we do for the rest of our lives. Number 2, how to assign a value to a variable using the assignment operator. That can be a value that is A, a literal value, which means just a raw value, B, a value copied from another variable, or C, the value returned from a method. So those are our primary ways to get values right now, right? And all we need to do is put one of those things on the right side of our assignment operator. Assignment being single equal sign, which is going to be very important for the next few labs. A single equal sign does assignment. So anything on the left side is the variable that we are going to assign a value to. Anything on the right side should be something that results in a value that can be stored in the left side. The anatomy of a method, including the parameters, arguments, and return types. Again, I put an infographic on the announcements on Discord, so anybody who still needs that, download that thing down. Remember, you have the whole of the internet to use as a resource, just always tie it back to our first-party resources. How to return a value from a method using provided input. This is your lab 2 and 3 stuff, right? So you are given a value stored in a parameter, you use that parameter inside of the body of your method, and then you return some type of result based on that given input, right? We wouldn't give you that input if it wasn't important. You wouldn't bother defining a parameter list if you didn't need all of those parameters inside of your method, right? And then finally, how to call a method and provide it with data using the values to determine the result. So that is calling a method, passing arguments that will be assigned to those parameters. Any questions about any of that? Good. In addition to that, by this point, you would ideally be done with all of your Lab 1 assignments. All right, so we are now on Monday. I know they are due by 12 p.m. or 11 p.m. today. But again, we're starting new content here, right? We're on to new stuff. So ideally, you'd be done with that. Have a good understanding of all of that, at least like a 70% understanding, right? That would be ideal. And then ready to move into this. So like at minimum, where I would hope that you would be at this point is understanding how to take in values and use those values to get an expected result. If you're still struggling with created methods, you're gonna have to create methods for the next 2 labs, so you're gonna have more practice on that. But you know, ideally you got from today's earlier discussion what you needed for that. So let's keep going. So the theme for this week will be program flow control. So anybody out there ever play like, I don't know, Satisfactory, Factorio, Timberborn to a lesser degree, any one of those games? You have a lot of conveyor belts, right? Sometimes your conveyor belts go into Y splitters or 3 splitters, go into other conveyor belts. So you have to control, you know, how your resources are being split up and where they're being sent. That's effectively what we're doing in our application, right? We are going to control what is going where and how it gets there. So program flow control is going to be us designing the mechanisms that show the flow of how our application runs. So when we follow that, that's going to be known as our code path, right? So the path that our code takes as we execute it is going to be our code path. It is going to change based on certain conditions. So like, you know, what's the value? What happened here? What's going on here? So certain conditions are going to change the path of the code and the end result of our application. So here's an example of a diagram, flow chart, that just shows three different potential endpoints for this particular circumstance, right? So, if the lamp doesn't work, the first thing is we hit our first decision. Is the lamp plugged in? If the lamp is plugged in, we move on to the second decision. If it is not plugged in, we plug in the lamp. So if it is plugged in, we go to a second decision that says, is the bulb burnt out? If the bulb is burnt out, for those of you that are younger, that is what happened to light bulbs back in the day. After like 2 or 3 years, the filament would break and we'd have to replace them. LEDs don't do that as much anymore, so you may have been born right now and had a light bulb your entire life, which was not a thing back in the day. But anyway, the bulb is blown out, replace the bulb. Otherwise, there's probably a problem with the lamp. So there's 3 potential endpoints for this one set of execution, right? So that's the kind of thing we're going to be running into. So I'm saying this condition thing a lot, right? And a condition in general is just like a variable result, right? So like the weather conditions outside, it could be rainy, it could be it could be a clear day, it could be a cloudy day. Those are all different results, variable outcomes of the potential weather outside, right? Conditions are going to be similar in programming, but what they're really going to boil down to is true or false. So it's going to be us asking a question, and they're always 100% of the time going to be yes/no questions, right? Sometimes they are a series of yes/no questions, but the answer will always be true or false. So we're going to have our bool data type here, right? We're going to use our bool data type a lot because our bool data type results in a true or false value, but it's going to be interchangeable with a bunch of other things, right? For instance, when we do comparison, those comparisons are going to result in true or false. Those true or false values may be assigned to a Boolean variable, but do not have to be. So here we can see Boolean typed value set to success. This is the easiest condition we have. We can make a decision based on the value stored in success. Either yes or no. Done. So let's make this a little bit more contextual, right? Here we have another Boolean value. This one is called eligible to vote. And it is set equal to a conditional comparison. So in here, we are comparing 2 values to get a yes or no answer. So is age greater or equal to 18? So is the value that's stored in the age variable greater than or equal to 18? If it is, if there's at the value of 21 is stored in age, then this condition will resolve as true, and the true value will be stored in eligible to vote. If it is not, then it will be, like if there's 16, it will result in false, and a false value will be stored in eligible to vote. It's going to be one of those 2 outcomes, but the outcome will change based on the value stored in age. Any questions about that? Cool. Now these parentheses are not necessary here. They're strictly for visibility purposes. Parentheses will generally perform order of operations because everything we're doing here is just more different math, right? It's very math-ish, it's very math-y. But in this particular circumstance, I only have those parentheses there to make it easier for me to read the code, because for me, having 2 equal signs like that is a little bit difficult, right? You can do whatever you want. All right. We can also do compound conditional statements. So here, we've added a secondary condition to this question, right? Are you over 18 and are you registered to vote? Because being over 18 by itself does not necessarily mean that you are eligible to vote. So here we use that double equal sign to do a second comparison to result in the overall result of this comparison. 2 things here. Number 1, my pen is missing. Hold on. There we go. Number two, wait for my pen software to load up. There we go. Here we have our comparison operator. It looks similar to your assignment operator, but there are two equal signs here. So two equal signs means we are comparing two values. In this case, we're comparing the value that's stored and registered to vote to a literal value of true. So if the value stored and registered to vote is true, then this whole section returns in true, right? Then same thing over here. If the value stored in age is equal to or greater than 18, then this is also true. If both of these are true, eligible to vote is true. If either one of these is false, eligible to vote will be false. So, true and true, this results in true. True and false, this results in false. False and true, this results in false. False and false will also result in false. This is a truth table. You're going to be, we don't use them a lot here, but they are relevant quite a bit. You should have been introduced to them in some degree when you talked about binary matter, conditional math in discrete math. But is there any questions about any of this so far? Cool. In addition to this, I could also put this in parentheses if I wanted to. That made it easier to read. It is what it is. Whatever I need to do in order to make this easier for me. So the double ampersand is our and operator. You can read that literally as and. So remember, what we're trying to do here is make our code as human readable as possible. So I want to be able to read this line of code as a sentence. So if I say, you are eligible to vote if your age is greater than or equal to 18 and you are registered to vote. That's it, right? 1 ampersand, a single ampersand in C++ is an operator for something else. The same way that a single equal sign in C++ is used for something else. So we have to use the double and. And for what it's worth, double and is going to be your the and operator for every single language I've ever used. So it's a common pattern as well. All right. So at this point, you should understand Boolean values can only hold a literal true or literal false value. You should understand how comparison operators can be used to compare two values to return a Boolean result, true or false, and how logical conjunction operator, which is your and, can be used to combine multiple comparisons, right? Now, we're gonna look at way more of those. There's a lot more to talk about, including all the other operators, but that is your base introduction to concepts we're going to discuss today. Are there any questions about any of that? All right, so it's 1:55. We're going to take our first break. We're going to come back here at 2:10, and then we're going to get deeper into this. So I'll see you guys all in a little bit. All right, let's get back in. And this is exactly what I mean, just so you guys are aware, stuff like that. This is exactly what I mean when I say, like, I don't want to see your code, because generally speaking, I based on the errors that you have, I can kind of decipher what your code problem is, right? Number one. Number two, I'm going to use those like context clues in order to try to resolve what the compiler is saying. So you have an opportunity to see me work through the same stuff that the same way that you would work through it. And if I see your code, I'm just going to give you the solution, and giving you the solution doesn't help anybody, to be honest. Like sometimes there are some certain circumstances where somebody does something that's a little bit off kilter, where else you need to be like, I just need to see it. But most of the time, like I would like to point out what your error message is doing so that you can go and solve the problem. Because if I solve the problem for you, you don't get the memory of solving it and absorb the solution better, if that makes sense. All right, so let's get into it. So conditional statements. So conditional statements are going to be statements that make different outcomes based on decisions. All right, so there's gonna be a few different ones we're gonna talk about. The most basic one that we're gonna talk about is going to be an if statement. Again, we are gonna try to make human readable code. If statement is gonna be a big part of that. So if the condition is true, we're going to be given a condition. If that condition evaluates to true, we execute the body. Otherwise, we don't. That's it. So this is what an if statement looks like. If statement says, if condition, do the thing. All right. So we're going to take this condition, right, and we are going to replace it with the logic that we saw previously. So here we go. If age is less than or equal to 18 and registered to vote is not equal to true, so we changed it up. Whereas before we did equals equals, now we're doing basically the inverse comparison, which is not equals. Anytime you see an exclamation point in code, anytime you see this, you can generally read that as not, right? Not 100% true, but if most code will be written in that particular way. So if age is greater than or equal to 18 and registered to vote is not equal to true, otherwise read, they are not registered to vote, then we register them to vote, right? Again, both of these things must be true, right? So both of these things must be true. This is easy, right? This one though, right? This one is registered to vote is not equal to true. We could have also written this, registered to vote is equals true false. And if this is false and this is false, then that whole thing equals out to true. Does that make sense? All right. This is where people will start falling off. This is where people panic and have difficulty and start to not understand this as well, because week one is just like typing stuff out the right way for the most part. When we get into week two, you actually have to like solve problems where you are now playing a puzzle game, right? So even if you understand the syntax, even if you write stuff out correctly, if you're not that great at solving the puzzles, right, that's the skill you need to focus on. Majority of the class from this point on will be figuring out those puzzles. All right, so, yeah. So, oh,
So just as long as that you hope that helps get better.
here, let's do this. Aside, pause. Give me a second. Actually, you know what? I'm not going to launch Steam. I'm not going to do that because I already know the new and trending on Steam is going to be a nightmare. Let's do this. Let's go to Steam, steampowered.com. So there's going to be a list of games that I would recommend that you play if you struggle with this or if you just like games. The first and most important is going to be Human Resource Machine.
Oh, they produced it.
Human Resource Machine is a video game that uses conditional logic to solve puzzles. These puzzles And this logic is going to be very similar to a visual programming language developed by MIT that's used to teach children to program called Scratch, right? So basically, human resource machine uses Scratch in order to make a puzzle game, right? So very recommended. In addition, human resource machine has a sequel. It's called 7 Billion Humans. It's just more human resource machine. So also very good at this. In addition to that, both human resource machine and 7 billion humans have the programming tab. Now, programming tab in Steam comes with an asterisk, right? There are going to be things here that are helpful and that are good because they teach you the same patterns that you would use in programming. And there are things in here that are just programming. So if you don't know programming, they're not as helpful. So let's take a look. Let's go down to the list. Where's the list? I guess this is the list. It's just a lot bigger now. The farmer was replaced. I like the farmer was replaced at all. It's an automation game. It's an automation idler game. However, you have to code. So you have to code Python. You will unlock different skills over time. And by different skills, you mean like different programming functions, different programming things. Like you unlock if statements later on. You unlock loops later on, things like that. I enjoy it a lot, but it does require some level of programming. You can start off not knowing any programming at all and get off the first few bits of it, right? And that'll help you. But beyond that, you're gonna have to do a lot of problem solving. It's heavy problem solving, but it is very good. Number 2, Baba Is You. Probably one of my favorite games of all time in this genre. Baba Is You is no programming, and it is literally just all problem solving. So the game itself functions like your code. And I say that by that I mean it only does exactly what you tell it to do. And if what you tell it to do does not necessarily make sense, it's still going to do that thing. So in this game, the instructions for the stage are written on the screen, but you can change the instructions. Your goal is to get you, whatever you are, to the flag. So here you can see Baba is you will move around. Here you can see rock is push, the rock is pushable. Now it says rock is you are now the rock. It does exactly what it's told. Wall is stop, Baba is you, wall no longer stop. So, even if it doesn't seem like programming, it is very adjacent to the types of problem solving patterns that we would use to solve code. So I highly recommend Baba Is You. It's just a fun game too. There's at least one more here. To a lesser extent, like I said, Satisfactory and Factorio are programming games. I'll show you a video on that during the next break. This guy, Joy of Programming. It's not as well received as some of the other ones, but Joy of Programming is a game that's designed to teach you programming, that's developed by a German computer science professor. The primary goal here, what it does, is it visualizes what's going on in your code. So like this is a conditional statement, right? So there's a scanner here. If whatever is dropped is equal to box, go this way, else go this way, kind of thing, right? So that's the scanner. If the scanner reads box, conveyor belt left, if the scanner reads barrel, conveyor belt right. So it visualizes programming. This is also written in Python. In my experience, the optimization is a little not quite there. So it's a little bit wonky, but it does work. Your guys' laptops would be probably more than fine. And also, Python is weird and it does take a bit of getting used to the syntax. But again, if you're just struggling with the logic part, you're pretty okay with the syntax and you're okay swapping between languages, fine game. But yeah, those are all good starting points. If you're interested in just puzzle games for this. To a lesser extent, any type of a deductive investigation game, Overdin, Ace Attorney series, Young and Rockla, any one of those is like good for debugging as well, because debugging is just those things. Yeah, what's up? Bitburn? Not. Is it on Steam? Oh, this is just what, JavaScript? Yeah, JavaScript. This is just work. It's just. Yeah, I see that. Yeah, it's a free game. I will try this. I'm also going to give this to my friend who actually is better at JavaScript than I am. There's also Wild True Learn. This will be the last one. This one's a little bit more extreme. It's both more extreme and less extreme in the same way. This is specifically to learn how to teach AI programming. And granted, this is AI programming in 2019, so not like large language learning models, but like at least a learning model of some sort. Neural network, say. But it does use a node-based visual programming thing. So again, you don't need to know how to code stuff, but you do need to have like some really hard problem-solving skills. So all those guys are good just to help you out with this kind of stuff. All right, back to actual code here. So we have our original if statement, and now we've given a secondary back. What's the word? It's to fallback. We have a secondary fallback. So if the condition of the if statement fails, right, we have a second thing that happens. So if they are either not old enough to vote or not registered to vote, right now the program just assumes that. If they do not need to be registered to vote, right? So if they do not need to be registered to vote, the program automatically assumes that they can vote based on the logic that's written right now, right? So the problem here is, even if they are over 18 and registered to vote, right, does not mean they are eligible to vote, right? So they are voting even if they're not registered to vote. So while this was really good at checking to see if somebody needed to be registered to vote, it's not necessarily good at checking whether or not they can vote. So what we really need here is we need another condition. If the first set of conditions fail, we need to check a second set of conditions. There's two ways we can do this. Number one, we'll look at this more in a little bit, we could nest a second conditional statement inside of our first conditional statement. Number two, we can provide a secondary check here in the form of an else if. So here we have if age is greater than or equal to 18 and they're not registered to vote, register them to vote. Else if age is greater than or equal to 18 and they are registered to vote, then they can vote. So this changes up the way the logic is written. Now, you may be looking at this and saying, this is kind of getting a lot, man. There's kind of a lot going on. And you would be right. There's a lot going on here. This is not super optimized code. This is code to prove a point. And we can also tack on an else here as well, right? So we can have as many else ifs in between our initial if and our final else as we want. We call that an else if ladder. So it just checks a bunch of stuff all the way down. Whether or not that is a good idea is arguable, right? But it is functional. It will work. So one takeaway we have, like I said, this is kind of a lot going on here. It doesn't help that register to vote is a long variable name. But one thing that we can observe here is we can see we are doing this check twice, right? So realistically, if they are not equal to or greater than 18, we don't need to run any of this anymore, right? If that check fails, like if that check fails here, we check it again here, right? And that doesn't make sense. If that check fails, we should just be done, right? So not only is this code like hard to read, it's also not the most efficient. So what we can do is we can take that initial check and put it in its own check, which looks like this. So now this is known as refactoring. This is taking our existing code, changing it up to make it easier to read, right? Maybe the execution is slightly different, maybe the execution is the same, but in general, we're just using it to come back, look at this stuff, and do it in a different way. So now we say, if they are equal to or greater, if their age is equal to or greater than 18, that is when we'll check their voting eligibility. Otherwise, if this person is not even 18, then that's not even a thing that we are concerned about. Their voting eligibility, we already know what their voting eligibility is. We do not need to do a secondary check on it. So we could have like, we could still tack an else on here and say like, I don't know, take a politics class or something, or read a book or something, whatever. But you can do that, but we can just skip that whole, that secondary check, which in turn makes our code a little bit more efficient too, because we don't check the same thing multiple times. Any questions about that?
Yes, is that the syntax for where it's registered to vote, or do you put something in parentheses in there in the single on vote?
That's assuming, this is just assuming that we had these ethereal methods that did not require parameters that did a thing, right? So these are made up. We can assume right now that they don't require parameters, if that makes sense. All right, now, what we made up for in complexity and the length of the lines of code that we have to read, we have now introduced more complexity in the amount of nesting we have, the amount of brackets we have, and the amount of lines that we have. This is going to be a recurring theme in everything that we do from this point on, because like I said, from before this, most everything could get done in like a maximum of 3 lines. That will not be the case moving on. And you will have a lot of things nested in brackets, right? So this is where things like your rainbow brackets and your rainbow indentions are going to become very important. One of the most difficult things for beginner programmers to do is manage their white space and their scope beginning and end of brackets, right? If you miss a bracket somewhere, it's going to break half your application and the error is not going to be super helpful for figuring it out, right? So you really want to make sure you are keeping track of where your brackets begin and end and that everything is lined up correctly. And having rainbow brackets helps you do that because you can see, okay, here's our orange brackets. These are all like the first set of alignment. Here's our yellow brackets. These are our second set of alignment, so on and so forth. So keep track of those things. Use every tool that you have at your disposal in order to do that. All right. At this point, you should understand how conditional statements change the outcome of the application by providing branching decisions based on Boolean conditions. So if something is true or false, something different may happen. There's a lot of words to say that. Number two, how the comparison operators help create conditions that can be used to determine the execution of conditional statements. So all of our comparison operators, equality, greater than, equal to, all of those things will result in two things being compared to each other and something either being, the outcome either being true or false. That's it. How if statements allow us to check several conditions to result in several results. So if just doing one or two checks is not the right way to go, we can do secondary checks as far as we need to go. Or how nesting allows us to prioritize and group up certain conditions to avoid unnecessary secondary checks. Any questions about any of this? Cool. Moving on, a ternary statement. So a ternary statement, the word ternary means it is comprised of three elements. A ternary statement is another type of if statement that can be used if we are using an if statement to determine the value of a variable. What it does at the end of the day is it poses the variable, it poses the condition as a question. Some people like it, I like it, some people hate it. So let's look at some code here. So this is code that says we are going to determine the price of a product based on whether or not there's a discount, right? So we have the price. Right now it's not initialized with any value. We could initialize it with a default value, right? But we say if there is a discount, so if discount is equal to true, then the price is $3.94. Otherwise, the price is $5.25. So if there's no discount, the price is $3.25. There is a discount, the price is $3.94. Makes sense. Easy. This is perfectly fine, valid code. But it can be simplified. And many times you'll find that you could probably remove the else statement. So here we can see if we set the price by default at $5.25, then we only need to check if there's a discount to change it. So the price is $5.25 unless there's a discount, then it's $3.94. Make sense? Cool. Next up, one of the things that we've been ignoring for all of these slides is that the value stored in discount is a Boolean value. It is either equal to true or false. So there's no need for us to compare it to true or false because it itself results in true or false. So right now, if the value stored in discount is true, if there is a discount, we will run it. So there's no need to compare that. So we can remove that comparison altogether. Discount is already true or false. Any questions about that? All right, so the last thing we are going to do, we're going to convert this into a ternary. Ternary looks like this. We're going to initialize the price if there is a discount. So it says the price is there a discount, question mark. If there is, $3.94, else $5.25. So the price is, if there is a discount, question, this, else, this. That's it. Like I said, I like it because for me, this is more human readable because it poses it as a question. You don't have to use them. I'm just offering them up as a option. Like it's all of my code into one line of code. So the syntax is literally this: condition, if true, else. All right. The last conditional statement we're going to discuss is a switch statement. So a switch statement will compare a single value against multiple other values. Those values are going to be presented as case. So in the case of X, do this. In the case of Y, do this, so on and so forth. Depending on the language and the version of the language that you're in, switch statements can do different things. For example, sometimes they can check strings, sometimes they can check ranges. It varies. However, one thing that they can reliably do all the time is compare numbers. Computers are really good at comparing numbers. So if you are using numbers or some things that result in an integral value, an integer, then switch statements are great. So here we can see a fairly complicated else-if ladder. And what this else-if ladder does is it compares number up against several other values. So if number is 1, do this. Else if number is 2, do this. Else if number is 3, do this. Else do this as a fallback. So if number is 1, 2, or 3, do one of those things. If it's none of those things, do the fallback. Any questions about this? Does this make sense? Cool. Now, since we are comparing one thing against multiple things, this is a good opportunity for a switch statement. So here is what this would look like as a switch statement. So now we take in number as a parameter to the switch statement, and we compare it equal to each one of the cases. So the case keyword is the prefix, and then the 1 is the value. So this is the prefix, this is the value we're comparing against. Prefix, value, prefix, value. There's no brackets necessary here. The indentation is recommended. So this says, okay, we're gonna take number 1, we're gonna take number, we're gonna compare it against 1. If it works, we're gonna do this. If it doesn't work, we're gonna compare it to 2, then we're gonna do this. And if that doesn't work, we're gonna compare it to 3 and do this. And if all else fails, we're gonna default out to this. Any questions about that so far? All right, so this comes with a caveat. You can see here, for each one of these, we have this break keyword. So what the break keyword does is it automatically exits a conditional statement. Or if you hit a break, you leave the conditional statement. So once we hit that break, we exit out of the switch case statement. This is important because switch statements are designed to have what's known as fall through. So that means that if we hit this condition, boom, and that condition is true, we will do this line, but if this break isn't here, we will continue doing every single other line until we hit a break, right? So once one condition is true, it'll do everything. Sometimes that's good, sometimes that's a feature, sometimes it's a bug, right? Best way to catch that, does anybody know what the best way to catch that might be? What's up? I mean, you could do a check in there, yes. And that's the answer I expect to hear from somebody who does web development. But the actual best way to do it here would be to have breakpoints. Because if a breakpoint is hit when you don't expect it to be hit, you know your condition's falling through when it shouldn't. So breakpoints are going to be your guys' best friend for a lot of this stuff. So here's an example of fall through happening intentionally, right? So we have case 1, case 2, and case 3. So if any one of these are true, we're going to hit that line. Otherwise, we're going to fall through to the default. The default, depending on the language and depending on the compiler, does not need to be here typically, and doesn't need a break typically. In the compiler that we will use in this version of C++, you must have both of these. Even if they do nothing, they must be there, otherwise it's going to break. Oops. It's not my eraser at all. So this switch case is the same as this if statement. So depending on which one you want to do, they're going to do the same thing. Whatever you decide to use is a stylistic choice. Any questions about this? Now, I can show you an example of where I used a pretty large switch statement in production. 2 key points here. It's going to be in PHP, which is the most popular web programming language out there. Most new applications won't be built on PHP, but the majority of the web is on PHP. And number 2, PHP differs from C in a C# or C++ in a few different ways. Number 1, it's not type sensitive. Number 2, variables are prefixed with $signs. And number 3, it can use string comparisons for, it's gonna be here. It can use string comparisons for switch statements, which we can't do in C++. But this isn't about the code itself, this is about the logic behind it. Helpers, oh, not helpers. This is the, it says 1 month ago. This is the new site, sorry. I gotta go back. I gotta go to the old site, the current site. Here, I go to the live site. Now we're gonna go to here. And we're gonna go to here. And we're gonna go to here. And we're gonna go to here. So context, real quick. This is the website that runs on compo.thesauce.net. So this is a website. It has different, basically these are like competition rounds. Each one of these is a different competition round. Those competition rounds can have different resources. So you can see here they have just the outline, which is the description. They have rules, which is like what happens, what the conditions of it is. But they can have additional resources. This one does not. I go to, let's go to People's Remix Competition. And we'll go to, here, sure, fine. So this is a particular thing. It has several resources. One resource is a audio resource. You can see here because it's got a little music note. The other one is a video resource from YouTube, so it just embeds it, right? So I have particular logic here that determines how all this displays and what it looks like. So that's what this code is. So we're going to come down here. Let me full screen this. This is a big old switch statement. So what this does, this is a method, right? Otherwise known as a function. So we have a function here. It takes in 2 parameters. They're not type sensitive because it's a PHP. They both optionally can be null, which means that I can pass this by itself with no values, but that's the whole different thing. We store a value here called extension that will take the file extension of a file name that's passed. So this is the file name. File was a bad variable name here, it's actually the file name. What this method does is it splits the string file name at the period, and it takes the end of it. So for instance, if I have like photo.jpg, what this code does is it searches the string for the period. It separates this into 2 separate strings now as a collection, which we'll talk about on Friday. So it separates it into 2 separate strings like this, and it gives me the last one. So it gives me JPG. Any questions about that so far? Cool. It then takes that file extension and passes it into my switch statement. This switch statement is used to determine which one of those resource icons I have, right? So this says if it's JPG, PNG, GIF, or JPEG, it's an image, break. This says if it's a mid, wave, MP3, XT, IT, or mod, it's a music note, break. If it's a zip or a RAR, it's an archive, break. Otherwise, we just have a default file icon. Then we make that ln, right? The alternative here would have been a really, really ugly if statement. It would have been if JPG or PNG or GIF or JPEG do this, else if mid or wave or MP3 or XM or IT or mod do this. So in this particular circumstance, this made my life a lot easier, right? What's up? Yeah. So you're saying is I load up all of these extensions into an array, and then say if it matches this index of that, do that, yeah. Oh, I don't know. I off the top of my head, I don't know. I have too many languages in my head, but yeah. Yep, and truth be told, if I had access to other tools in this, I wouldn't do it like this either. I probably would have used an enumerator to do this here, but we'll look at that in a second. But yeah, no, there's definitely other ways to do it. It's just in this particular circumstance, at this particular time, that's how I did it. But yeah. So, but this is just an example of how to use a switch statement to simplify what would have otherwise been a really ugly, what would have otherwise been a very ugly if statement. That also does remind me, by the way, there's a new operator here that we didn't talk about, and that is double pipes. So double pipes here, these guys are your OR operator, right? So we have ampersand, ampersand, this is an ampersand, it just looks really weird. This is and then we have double pipes, this is OR. Right, so in the OR statement, so ampersand, double and, we said like true and true is equal to true, true and false is equal to false, false and true is equal to false, and false is equal to false. In the OR, true and true
equals false.
is equal to true, put it over here. True and false is equal to false. False and false is equal to false. And false and true is equal to true. Right? Now, that makes sense. However, and or, what's up? For this one here, true and false? Yes, this will be true. You're right. That is true. Was it that question? Okay.
And then or.
One is these can be, not always, but they can be interchangeable depending on what you're doing and how you're checking things and stuff like that. But one thing to keep in mind, right? In the and, if this equals to true, it will always check this, right? In the or, if this is true, it does not check that. Doesn't need to, right? In the and, if this is false, it does not check the second one. In the or, if this is false, it has to check the second one. So, you can get very, 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 very microseconds of optimization by writing this in a particular way. It is something to consider. And again, you'll get used to those patterns later on as you look at this stuff. I'm not expecting you guys to make super efficient code right now. I'm just expecting you guys to make code that works. But there are options available. And that's one of the things you're gonna need to come to terms with these assignments, is there's a bunch of different ways to solve them. There's no one true way to solve them. People will have opinions on what the true way to solve them is. There will be a most efficient way to solve them. But just because it's the most efficient way to solve something does not mean it's the best way to solve something. The best way to solve something is the way that you reliably understand over time. That means if you wrote a chunk of code and it works, and you understand why it works, and it makes sense to you, then you come back 6 months later and you can still look at that code and it still makes sense and it still works. That is the best way to write your code, 100%. You can write the world's most optimized code, that is the code that runs super efficient, it's glorious, it gets the job done, and then 6 months from now, you need to add another condition to it, and you come back to it, you don't understand how it worked, and you need to rewrite the whole thing, you didn't save yourself any time. Keep that in mind.
That's true.
All right, so by this point, you guys should understand how ternary statements can be used to simplify conditional statements that are assigned, can be used to simplify conditional statements that are used to assign values by proposing the statement as a question. You should also understand how Swiss statements can be used in place of else if statements when comparing one value against multiple values. And finally, how the break keyword allows you to immediately exit from a conditional statement, which will be something that comes up often. Any questions about any of this stuff? All right. We are now at 2:57, so we're going to say it's 3 o'clock, and we're going to take our second break. What I will do for you guys, though, during this break, like I said, is I'll play a video. You guys don't have to watch the video, but I will play you the video. I'm on my wrong YouTube account, I think. Nope, here we go. I have a playlist for this. So here we go. You can watch this video. Stop the recording, and I will see you guys back at 3:15. Alrighty, but spoiler alert, we are gonna start this talking about another video. So we're not quite done with the slides yet, but we're done with the conditional statement stuff. And here we're just gonna talk about additional tools in the conditional statement. So the next thing I wanna talk about is this.
Programming is hard.
So this is a video by Code Sloth. Code Sloth is another YouTuber that I like to watch a lot. He does educational programming videos, but he takes them, whereas Fireship is like kind of higher level. Code Sloth is kind of a low level, going through how to learn programming more so than programming in general. Primarily web-based. Most people that you see on the internet will be primarily web-based, or let me put it this way. Most YouTube channels that you will find on the internet will be primarily game development based or web based. Anything that's software application based is primarily going to be based in India, because that's where a lot of those jobs are. Like Windows desktop development is huge in India, so a lot of those channels are going to be software. But the majority of like what you guys will generally encounter will be game development and web development. So that's the majority of the resources that we're going to see here. But yeah, this very, very good. This is a huge resource for this week. So let's go.
Programming is hard. Now, this is obvious to some of you. I can already hear some of you. No way, programming's hard. What's next? The sky is blue. The earth is a donut. There are some people, mainly beginners, who think it's easy. I think it's because of the day in the life videos that maybe show them working 1 hour and then eating lunch for another 7 hours, or influencers that are like, learn these technologies to get a 6-figure job in 3 to 6 months. Yippee! But surprisingly, programming, in terms of writing code itself, is the easy part. Programming at its surface seems like a straightforward task, right? Write some code that computers understand. However, the reality is far more complex, because programming involves logical thinking, problem solving, and a deep understanding of both the problem you're solving and the tools you're using. So what I'm trying to say in a smooth brain way, programming is not coding. Why? A lot of times people are missing an essential part of programming, the mindset, thinking like a developer. And this is the part that makes programming difficult for everybody, especially beginners. It's not the coding part, but the mindset. It's one thing saying, just go learn some JavaScript. It's gonna be easy. Learn it in like a week, bro. Don't mention this imposter syndrome, all the late night coding sessions, and all the time you just feel stupid when programming is not for you. That's it.
I'm going to say this a lot, and you're going to see a lot of videos that say the same thing. I'm not saying this because the videos are saying this. I'm saying this because we have all encountered it, and you guys will encounter it during this class too. This week will get difficult. You will run into a problem during this week that will make you feel bad. That's not like a threat. That is what's going to happen. Unless you have previous programming experience and get incredibly lucky, you will run into a thing this week where you will get stuck and get upset. It's part of the process. When you get upset, you will have feelings that will be like, this is way too hard, I'm tired, I don't know what I'm doing, I wasted all my money, maybe I shouldn't be a programmer, I just want to give up, this is just all terrible. Unfortunately, that is part of being a programmer. That is all part of the job, is you will feel those feelings. Over time, you will learn to not be as dramatic, but right now it's the first time you have ever faced that problem, and it's the biggest problem of your life, and you're gonna have a bad time. So I'm telling you this now, so that when you encounter that problem, you remember these words. You will get over it. It's part of the process. And nobody wants to hear this either, but the problem you are facing is probably that you're checking the wrong condition first, or that you have a typo. Like, there is no such thing as a smart problem in programming, which means every single problem you encounter was some kind of dumb mistake. You will always come out of every single one of those circumstances being like, that was so simple, I just made that stupid mistake. So, that is the thing. I'm not, hold on. Fullsail University will restart your device at 3:37 to finish an upcoming Windows update. What time is it? It's either, my options are confirm or restart now. All right, so 3:37, my computer's gonna restart. So let's finish this video, and I guess I'll restart my computer at the end of it.
Never brought up. And I think it's because it's something that tutorials and books can't teach. You have to experience that yourself. Let me expand more on this whole developer mindset thing and give you some tips to help you develop this mindset faster. Imagine learning to cook by only memorizing recipes.
Okay, hold on. I have to make this commentary here because this annoys me. He's talking about cooking. He says cooking. He's going to talk about baking. And ingredient substitution in baking is not the same as cooking. That's a huge different thing. Cooking, you can kind of just like, this feels right, it's cool. Baking is a precise science. And while his comparison for ingredients is technically correct, the terminology is way off. That's just a pet peeve of mine here.
Flour, sugar, eggs, and butter. And following the recipe, you can bake a pretty easy cake. But what if you're missing an ingredient, or added the wrong amount of an ingredient, or someone asks you to bake something else because they hate cake? If you've only memorized recipes, you might be at a loss because you understand the steps, but not the principles behind them. This is similar to learning programming languages without understanding the underlying principles of programming. So you're basically a worse version of ChatGPT. Knowing a language like Python or JavaScript is like knowing or memorizing a recipe. Sure, it's important, but it's not the whole story. You can memorize all the syntax, but the bigger question is, do you know how to use the syntax?
Code Slot absolutely hates tutorials too, by the way.
Loops, and lists work. You then learn how to create a list of numbers and print each number using a for loop. The basic tutorial covered it like this. The next step is now to find the average of these numbers. And the tutorial did it like this. Let's say, in your situation, I'm a strict professor and I don't want you to use the sum function because that's too easy. In order to calculate the average under this constraint, you need to understand what the sum.
You know what that was? That was the external resource policy. This exists, but you cannot use it because you have to solve the problem. One of the biggest complaints about this class, and it is something that I agree with 30%, is that I don't show you how to do everything that you need to do.
That's not the
Which
complaint.
is not true. That is
That's not the complaint. This is the complaint. This is the actual complaint. If 90% of the mistakes that we're going to make as programmers is going to be grammatic, and we're in an accelerated class, we should have a resource that has been optimized by the school, certified by the school, and acceptable within the bounds of the school for us to use, that will allow us to quickly have the answer to the problem that we have at hand, right? And what I mean is that there is absolutely no reason why, if you want me to build an array, that you can't give me one array. There is no reason why you can't do that. There's no reason why, if you want me to use an if statement, that you can't give me one if statement, right? I still have to figure out how to integrate it and incorporate it into the structure, but it should be working fucking code. It should be an if statement that works from start to finish, executable, runtime. You should have the ability to show me how to take this code and put these two codes together to have them work together at runtime, because the other variables and the other values that go into that are going to have to be something I'm going to have to figure out. But how do I figure out how to even formalize the answer to the problem as a question if I don't even know how to write the language, right? Like, I can literally sit down right now and write anything in English, but I can't do basic kindergarten level grammatic structure for any other language outside of my native language. And nobody can. The average person cannot just go to some other country and sit down with kindergarten students, little kids that are first and second grade with no prior knowledge in language, and compete at the same level as those children, even though they will be fluent in their own language. That's the grievance. The grievance isn't, this is the structure and you can't go outside of it. The grievance is, why do you tell me to go outside of the structure and go try to find the solution to the problem, only to later tell me that the solution I found violates the actual policy of the school? That's counterproductive. How about you just give us fucking code and say, this is an example of everything that you should be able to do. And this isn't just a snippet of code. This is a working if statement. This is a working case ladder. This is a working boolean. This is a working array. These are all of the things that you are expected to do working. Now take this and apply this to your assignment. Because you might give me an if statement, but if the assignment requires me to write an else statement, I can't use the if statement. I have to use the else statement. So I should be able to take the if statement and take some other chunk of code and combine them together based on the steps that you want me to follow, and then build an else statement. And that's the actual grievance. That's because everything he's about to say, that's not the problem. The problem isn't that we need people to sit. You can't learn anything in life. And this is coming from years of being a manager and a supervisor. This is coming from, I taught a young girl off the street. She was a private, straight out of NTC. I taught her how to pick up a matrix with an LHS, a big ass truck in the military. She had almost no experience driving, but I was able to get her comfortable with picking up the matrix and driving the LHS within a few weeks. And then you want to give me a fucking 0 because I went outside the scope of the material. I don't need you to teach me how to follow fucking directions. I don't need you to do that. I didn't come to school for you to teach me how to be obedient and be in compliance, especially when my 2 cents is about not being in fucking compliance. I didn't start my 2 cents to be in compliance. I don't want to be in compliance. I want to be ethical and moral and obey the laws. But why would I want to comply to a society that wants me to be a fucking nigger? I don't want to do that. That is not the person that I want to be. So why would I do that? Why would I come to your school and accept that I need to be an undereducated, ignorant African American male? I don't want to do that. I'm not going to try to be a token. I'm not going to try to climb to the top of the ladder and have everybody love me and be my friend and come in here, speaking slang and rapping. This is not why I'm here. This is not what I need to do. And looking at me and seeing my skin and my hair texture and expecting that of me and then feeling betrayed when I choose to just be an American citizen is not an adversity that I should have to deal with every day, right? So that's the reality of what the actual problem is. That's the reason why I'm live streaming this, because at the end of the day, all I want to do is learn how to program, and everyone wants to act like ChatGPT is the devil. Like, no. Large language models are a new piece of technology the same way that Windows replaced DOS. Same way that Windows came in and replaced DOS, in the same way that iPhones completely destroyed the entire cellular phone industry. That's what happens all the time. And these people don't want to be disingenuous. This same teacher right here, right now, has this super hard point about how he doesn't like large language models and they're the devil and they suck and they're stupid and you shouldn't use them. Within 2 fucking years, the same teacher will be sitting in that same chair in front of the same exact class saying the exact opposite thing he's saying right now. The exact opposite thing. LMLs are great. They're awesome. I've always thought they would be amazing. I couldn't wait till they were being applicable to the system. This school is great. It's awesome. We've always had, this is the bullshit that adults do to children all the time in our society. And it's like, why? Just why? Why? Why did we develop these giant brains to be able to solve all of our problems just to create more unnecessarily complex problems? Why? Why is that a thing? Why? That's the reason why I started my 2 cents. Self-improvement through self-education. And he's gonna rant and rave and say all this stuff about how he can't really help because you need to be able to solve problems on your own and you have to be able to work inside of a structure or anything in that kind of ballpark. But the reality is, and I've said this 1,000 times and I'll say it again, I'll put it in the context this way. When I was working in McDonald's, the front cashiers, the managers that would work up front, would always say, that's too much stock. We would bring the sauce in the back of the store. So we'd bring up sauce cups to the front. She'd say, that's too much sauce. Take some of that back. And so I'm like, okay. So I'd try to stock it, I'd take it back. I'd try to stock it, I'd take it back. And so one day she irritated me so much, I said, what is the correct amount of sauce? And she looked at me like a deer in the headlight. And she's like, you just put the amount down there that's correct. I said, if you understand that there is an incorrect amount, because you keep saying that I'm bringing up too much or that I'm putting too much down there. If you understand that there is an incorrect amount, then you must have some value by which there is a correct amount. No, you just got to just put the right amount down there. I was like, well, then you're just making shit up. It's just based on how you feel, and that's really arbitrary. Today you feel like this is enough. Tomorrow you'll feel like you need more than this. That's counterproductive. I need you to figure out what the correct amount of sauce is. I just need you to do that. And that's just the reality of just living in the world. They say that there's an infinite number of ways to get things wrong in the school. There's an infinite number of ways you can get things wrong in the school. There's an infinite number of things you can do that are outside of the scope of the class. There's an infinite number of ways for you to make a mistake, right? But they don't provide you the finite amount of things that you can do. And they'll say, you can use all the resources we're giving you. If you're giving us resources, right? Not me. I'm just saying in general. If you've been doing this for several years, I think Fullsail has been around for at least 40 years. Well, Fullsail has been around at least as long as, let's just say for sure, Full Sail has been around since at least the 90s, since at least Xbox, right? If you've been doing it for this long and people have been saying the same thing and giving you the same grievances, when are you going to realize that there's an issue? You gave us all of these resources and we're still surfing the internet trying to find the answers as fast as possible because of the fire you're putting under us. When are you going to realize that there's something wrong with the way that you're providing your resources? At what point are you going to check yourself? They're never going to, because that's the way it's designed that way. It's designed for 75% of people to drop out, because everybody that drops out of programming one winds up going to another discipline inside of Full Sail. So it benefits the school because they don't have as many. Most of the people that are coming there for programming want to come there to be a game programmer. They don't want to do anything other than that. But by the time you get invested in the school and you get sucked into putting your time and energy into it, and you get locked into this lifestyle and this way of life, as soon as you realize, oh, I'm not really good at programming, the counselor sits you down and convince you, no, don't go to another college and learn how to program. Yeah, there's plenty of other colleges. Like if you can't take an accelerated program, if you're in an accelerated programming class and you can't handle accelerated programming, logic dictates just go to a regular 4-year degree college. If you can afford Full Sail, you can afford a regular 4-year degree college. That's what logic would dictate. But since they have their counselors and their instructors and everybody whispering in your ear, especially when you're young, then the most logical thing for you to do is to just change your course in the school to a different discipline inside of their institution. And they like that. They like that because it gives them more people doing different things inside of the school outside of what they otherwise would have been doing. Everyone that fails programming at Full Sail winds up taking something different in Full Sail. So it doesn't even, they don't lose anything. Like they don't lose anything. You take this class twice, you're not able to pass this class, you wind up just going to take something else. You still wind up getting a degree in something else. And the only thing that happens is the other classes get bigger. And they keep the number in the game development low because it makes people feel like, wow, they was really have a really difficult programming course, because so many people, it's very few people actually graduate from this course. And that's not really the case. That's just the way the institutions are structured. So I've ranted and raved. I will let him defend his position. And yeah, I'm probably gonna go to sleep after this.
Absolutely not true. I don't show you how to. You know what that was? That was the external resource policy. This exists, but you cannot use it because you have to solve the problem. One of the biggest complaints about this class.
Let's say in your situation, I'm a student professor and I don't want to do this because that's too easy. In order to calculate the average under this constraint, you need to understand what the sum.
You know what that was? That was the external resource policy. This exists, but you cannot use it because you have to solve the problem. One of the biggest complaints about this class, and it is something that I agree with 30%, is that I don't show you how to do everything that you need to do, which is not true. That is absolutely not true. I don't show you how to get the answer, because you need to get the answer.
Showing us how to get the answer is the job of a teacher, right? Showing someone how to get the answer is the job of a teacher. If I write 1 + 1 = and you stare at it and you can't figure it out, my job as a teacher is to get you to try to figure it out. Help you, walk you through the steps of thinking it through and trying to figure out how to solve that problem. And sometimes, as an instructor, the only way to teach is to, okay, this is 1 + 1, which is your problem. Here's 2 + 2 = 4. And 3 + 3 = 6. And 4 + 4 = 8. If we look at these patterns in this area over here, what about what we're doing over here correlates to what's going on over here? And here's the number line: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the number lines, and we can see that 3, 4, 5, and 6, 3, 4, 5, 6. We can see 4, 5, 6, 7, 8, 4, 5, 6, 7, 8. So if we have 1, and we need to go from 1 to 1, how do we get? That's literally just called teaching. It's literally just called teaching.
But I do show you how to do all the things to do everything that you need to do, which is.
You then learn how to create a list of numbers and print each number using a for loop. The basic tutorial covered it like this. The next step is now to find the average of these numbers, and the tutorial did it like this. Let's say in your situation, I'm a strict professor and I don't want you to use the sum function because that's too easy. In order to calculate the average under this constraint, you need to understand what the sum.
You know what that was? That was the external resource policy. This exists, but you cannot use it because you have to solve the problem. One of the biggest complaints about this class, and it is something that I agree with 30%, is that I don't show you how to do everything that you need to do, which is not true. That is absolutely not true. I don't show you how to get the answer, because you need to get the answer. But I do show you how to do all the things to do the thing that you need to do. The instructions need some clarification in some places. So since you guys are having me teach the class this month, when it comes up, I will clarify things where I think are necessary. But everything you guys need to do read 37 to finish an upcoming.
Create a list of numbers and print each number using a for loop. The basic tutorial covered it like this. The next step is now to find the average of these numbers, and the tutorial did it like this. Let's say in your situation, I'm a strict professor and I don't want you to use the sum function because that's too easy. In order to calculate the average under this constraint, you need to understand what the sum.
You know what that was? That was the external resource policy. This exists, but you cannot use it because you have to solve the problem. One of the biggest complaints about this class, and it is something that I agree with 30%, is that I don't show you how to do everything that you need to do, which is not true. That is absolutely not true. I don't show you how to get the answer because you need to get the answer. But I do show you how to do all the things to do the thing that you need to do. The instructions need some clarification in some places. So since you guys are having me teach the class this month, when it comes up, I will clarify things where I think are necessary. But everything you guys need to do, I do show you. You just have to connect those dots. And that's exactly what he's talking about here. Like I said, CodeSloth absolutely hates tutorials because tutorials show you how to do a specific thing. But if you don't understand what that specific thing is doing, it's worthless. So you can't take that and put it somewhere else. But that's what he's going to discuss this bit here.
Function is doing. You should know that the sum is just all the elements added together. In the tutorial, you've learned how to iterate over lists with for loop and perform basic arithmetic operations. So here's the alternative way to approach it. The tutorial didn't explicitly cover this, but it taught you everything you needed to solve this on your own. This example is pretty simple and kind of dumb, but unfortunately you'll encounter a lot of situations like this. Situations like you can't use this library, you can't use this framework, or there's times where a built-in function in one programming language doesn't exist in another. In cooking, this scenario is similar to adjusting a recipe based on a dietary restriction. Maybe you can't use a common ingredient like sugar. Instead, you have to substitute it with some alternative. You weren't directly taught this substitution in the recipe or in a cooking class, but understanding the role sugar plays in the recipe allows you to make the necessary adjustments. In cooking, Once you grasp the fundamentals, you can start experimenting and creating dishes on your own. You're no longer just following recipes, you're creating them. The same goes for programming. With a strong foundation in the basics, you're not just copying and pasting code, you're crafting solutions from scratch. This is where the true challenge of programming lies. This is a programmer's mindset, problem solving and logical thinking. It's not just about knowing how to code, it's about knowing what to code. To develop a new feature or fix a bug, you need to break it down into smaller, manageable pieces, then systematically address each part. This skill is something that's often
To address your point, Brendan, I don't ask you to do anything in this class that you don't know how to do. Now, whether or not you know how to connect those dots is what we're actually focusing on. But some things in this class, I'm like, add these numbers together, multiply these numbers together, determine whether it's a right triangle. Most people know how to do those things. And I'm not saying this to you right now to tell you that what you said is wrong. I'm just trying to refocus this. You know how to do those things. What you don't know how to do is how to do that thing in the context of programming, right? So you know how to add a bunch of numbers together, right? You know how to do that. You don't necessarily know how to take each number in a set and add them together. So what I give you is the tools for, first of all, this is what a set looks like. This is how to get each number out of a set, right? And this is how to add numbers, just like he showed there. So, okay, if you understand how to get each number, you understand how to how the numbers are stored in the set, and you understand how to add numbers, it's taking those three things and putting them together. Now, sometimes those things sometimes the solution, and often the solution, will not be immediately apparent. Sometimes you need to test out different circumstances in order to arrive at a solution. A lot of people like sit down, get to one of those like later tests, like lab 5 and lab 6, and say, I'm just gonna solve it by sitting down and not trying to tease out a solution. But that's not how programming works. Programming works in an iterative process. Do I know how to iterate through anything? Yes, cool. Do I know how to iterate through a collection? Yes, cool. Can I iterate through the collection and get each individual number? Yes. Can I take the number and assign it to a new value? Yes. Can I take that new value and add it? So can I take that existing value and add a new value to it? So on and so forth, right? That stuff takes time. But again, it's like he says here, a lot of that comes down to the mindset. You gotta get familiar with the patterns and the tools and the mindset.
I love the tutorials because it's something you can't really teach. It's one of those things where you're just gonna have to figure it out yourself. I can give you all the tips in the world and examples about problem solving. And yeah, you'll get better and maybe learn it quicker, but to fully master it, you have to do it on your own. You have to experience it for yourself because you can't master a skill of solving problems if someone else is solving that problem, right? In my experience, these skills take the longest to develop. And this is because all the learning resources, so tutorials, books, courses, they can't really teach these skills because they're meant to show you everything, each step, the reasoning, and how it all fits together. Tutorials are meant to help you get better at programming by showing you how to do things. But in order to be good at programming, you also need to figure things out on your own, something your tutorials can't do because then it wouldn't be a tutorial. Pretty tricky, right? You need to balance using tutorials and doing things on your own. And this is why people end up in a situation where they know all this theoretical knowledge, but they have no practical knowledge. They know everything, but they don't know how to use it. It's one of those situations where you did too much tutorials and not enough things on your own. And this is when people start entering tutorial hell. And unfortunately, they may never escape it. Tutorial hell is a place where endless tutorials are watched and countless examples are followed, yet the ability to solve new or unique problems doesn't seem to improve. It's an easy trap to fall into. This is why the learning curve in programming is notoriously steep, because you need to balance.
Okay, I'm going to bed, but I think there is something that I want to say in the context of this conversation as an adult, as someone that has been alive for 42 years on this planet and has dealt with society in general. And I need something. I need something. Let me see if I can find the thing that I need. I know where the thing that I need is. This is a perfect example of having a problem and then solving the problem, right? And sure, this is fine. And there is a video that I'm gonna play because I think it's very relevant to what's going on in regards to me doing my homework, I guess. Here's my stream. What's that guy's name? Captain Cool. Here it is. This should be it.
Make the plan, execute the plan, expect the plan to go off the rails, throw away the plan. Make the plan, execute the plan, expect the plan to go off the rails, throw away the plan. Make the
So, when it comes to problem solving, because they said that problem solving is not a skill that can be taught, but it is a skill that can be taught. You have to learn how to think outside of the box. The problem with the world is when you as a person, okay, let's try to keep this real simple. One of the things that some people have in their house are gas stoves, right? So a gas stove has a flame, right? And if you ever have cooked with young children, and when I say young, I mean like 1 or 2, just barely old enough to walk on their own, they get very curious when they see fire. And the first thing they want to do is what? They want to touch the fire, right? So you as an adult, or even if you are just an older child, everyone that should be watching should be 18. So you as an adult, when you're sitting there with this child and you're cooking on this gas stove and they see this flame and they want to touch it, as soon as they reach to touch it, the first thing you say to them is, don't touch it. No, don't do that. Don't touch it. Don't touch that. It's hot. No, stop. It's hot. No, stop. Hot. No. So this is the process of learning and teaching, right? You're trying to communicate to them that this is hot, this is fire, don't do that, it's gonna burn you, ow, ow, ow. So you're providing these values to this child, right? And as this child is learning, as this child's curiosity is getting the better of them, because you're just making sounds and they don't understand what the sounds mean. You're saying stuff to them, but they don't understand what it is. It doesn't actually register in their brain yet because they're not used to it, right? But eventually, the curiosity gets the better of them whether you're present or not, and they touch the flame and it burns them. So now they have learned that's painful, and those sounds are going to be associated with that's painful. So now when you're later doing something, you say no, don't do that, or stop, they're going to associate, oh, that word no means pain, don't do that, or stop. And they're going to continue to build and grow. Now, there's another condition that they don't ever touch on when it comes to when you're at work, right? The other condition is what happens if you restrict that child from never having the experience of touching a flame, right? They're 2 years old, they never are allowed to touch a flame. They're 3 years old, they're never allowed to touch a flame. They're 4-year-olds, they're never allowed to touch a flame. They're 5 years old, they're never allowed to touch a flame. Eventually, they're going to continue to grow and evolve with this ignorance of the actual consequence of engaging in that behavior, and they're only going to have the actual obedient part, right? And this is a weakness of Christianity and a belief-based system where you just do what you're told because you're told to do it, and you don't have any foundational understanding of why you're engaged in a certain behavior, right? So they're not they don't understand the nature of fire, the nature of flames, the nature of heat. And so they just don't they never have touched it. They've never had that experience, right? So what does that do for that person? How does the person doesn't have that understanding, right? And what ultimately will happen is eventually they will have a relationship with that flame, but they're going to have that relationship with that flame later in life than they should have had it earlier in life without all of the necessary discipline and restrictions. So you'll see them tend to be a little bit more careless around fire than someone that understands that fire is hot. And that's the point that I'm making. A lot of times in society, when they say that you can't teach problem solving, you can teach problem solving. You can teach problem solving by properly educating the correct way to do something. If you constantly enforce the correct way to do things and understanding why you're doing, a perfect example is cooking food, right? You don't have to cook food. You don't. You can eat raw chicken. You can eat raw fish. You can eat raw meat. You can eat raw eggs. You don't have to cook food. You can eat it raw. You can definitely eat raw food. But the consequence of eating raw food is food poisoning, right? So we know the consequence of eating raw food is food poisoning. So there are certain things in the cooking process that are supposed to occur so that you don't get food poisoning, right? So why do we cook food? So that you don't get food poisoning. So what does cooking solve as a problem? It solves the problem of food poisoning. But no one calls it food poisoning prevention. No one calls it stuff like that. We just call it like cooking or I'm gonna eat healthy food. Like this is the opposite side of what you see in society when it comes to dealing with the bullshit. Because I call it the bullshit. And the reason why I call it the bullshit is because we understand as people and as humans and as adults that the reason why we have rules and regulations and laws and ordinances is to maintain order. And we don't like chaos until we're restricted from doing something that we feel we should be allowed to do, right? Nobody wants to stop at a stop sign, but if you're driving down the street and there's a stop sign, oh, that person better stop at that stop sign because I have the right of way, right? And this is the chaos. This is like the point. And this is the reason why I grabbed the box, because you already know how to solve problems. The problem isn't solving a problem. The problem is solving a problem in a way that is ethical, moral, and legal. Because sometimes you have to be within the rigid structure of human society. You have to do things that are moral, you have to do things that are ethical, and you have to do things that are legal. And you cannot do things that are unethical, immoral, or illegal. And so you get these boxes. And then you have these stupid rules and these stupid regulations that tell you to do things in a way that doesn't make sense to you because it's called a standard operation procedure. It doesn't have to make sense to you. It just has to solve the underlying condition that the human condition prevents, right? I don't want you to burn your hand on the fire, so I have a physical barrier that separates you from the flame, because I don't want you to even accidentally touch the flame. So I don't understand why there's grates on here, because this is the barrier between you and the flame. What flame? The flame that's behind that other barrier. This barrier prevents you from touching the other barrier. So there's like two levels of prevention. Well, this doesn't make any sense. It doesn't have to make sense. It's designed based on engineering and logical flow and the probability of humans being human. And it doesn't always have to make sense. You can absolutely, the point that I'm trying to make when it comes to the context of Full Sail University is I'm not taking a how to problem solve class. I'm taking a programming class. You should be teaching me how to write code on day one, because I've already taken classes up to this point to show proficiency in this other skill that you want to test. There's no need. We already have a class for that. We have a class strictly for the thing. They have those classes. So if I have a class for that, why aren't you just teaching me code? Teach me how to program. teach me the fundamentals of how to write a code that should be sit the computer and put this information in the computer with confidence that when I hit execute, then it will run, it will compile and run. Does it do anything? No. Does it provide output? No. That will come next course. But the introduction to programming should be, when you leave this class, you will have the ability to write Hello World, because Hello World is the first program that you write, and that's, to me, that's the biggest weakness of the class. It's not that they're doing anything necessarily wrong. It's just that they're not doing anything right. They are actively engaged in not doing it right. They are actively engaged in making sure that the course is set up in such a way that the fail rate will be higher than it needs to be, based on the way that it's structured. They structured it. They structured it that way. Their plan is to make sure as many students fail as possible. I don't think that's okay. And this BS about when it comes to large language models, listen, if you are 18 and you are not using, the only thing I would recommend to anyone that is the age of 18 right now is pick one AI software and master it. Just one. Don't use all of them. Just use one. Because they're all going to be different in their own way, and you should become competent in just one. I think that when it comes to most software, there's always this need to have these overarching interactions, and this needs to be kind of like this and that needs to be kind of like that, and we need to make sure that people are comfortable with this one and lock them out of that one energy. But when it comes to large language models, information is just information, education is just education. So Group or ChatGPT or DeepSync or Google AI, whatever one you're using, the personality is going to be the landscape. That's going to be the walled garden. And you're going to get used to the way that one particular model thinks and behaves and functions. And it's going to be hard to move away from the logic of interacting with that model and interacting with another model. The same way it's going to be difficult for you to go from talking to this person and talking to this person. But it's coming. There is absolutely no reason for anyone to pretend like the world is not about to change in a significant way overnight because of large language models. We're about to go through a recession. We're about to go through a depression. Like, it's all coming right now. And the people that are going to make it through on the other side are going to be the people that are actually using large language models. Everyone else everybody that chooses to procrastinate and wait to get disciplined and to get a good solid understanding of large language models are going to get left behind. And you're just going to be playing catch up. If I finish Full Sail at the age of 42 using ChatGPT as a study guide, the probability of me getting a job is significantly higher, not because I got a degree at Full Sail, but because I've been using ChatGPT since its release date. My skill set in ChatGPT, along with the capacity to have a degree with computer programming that was complemented by ChatGPT, actually makes me employable. That actually does make me employable, because they're going to start getting rid of educated people and replacing them with us, with the uneducated. The uneducated is about to move into the academic centers. They're going to get rid of everyone that has a college degree, because they're not teaching you anything. They're not teaching you how to think on your own. They're trying to put you in the box. They want you in the box. If you're not in the box, then you're using data, you're using external resources, and you're going to get a 0. They want you inside the box. So they're about to move past that, because they don't need it anymore. They have large language models to make sure that the standard operations of the company are always in compliance. If you do something you're not supposed to do, it doesn't matter. ChatGPT is already watching everything you do, and it can know exactly what you did when you wasn't supposed to do it, and it can go in and fix it for you. So that way, that the admin part of the job will always be correct, and it'll just flag another AI that will communicate that to some other person, and then they don't need it. They don't need us anymore. The only reason why the human condition is necessary at the administrative level for jobs is because you cannot hold a machine accountable and responsible. They're not leaders. They're not in a position of authority, and they never can be. As always, my name is Paul Emerson. I'll give you my 2 cents.